Understand the core chemistry concept. Collision theory: for a chemical reaction to occur, reactant particles must collide with sufficient kinetic energy, equal to or greater than the activation energy, EA, and in the correct spatial orientation. The rate of a chemical reaction is directly proportional to the frequency of these effective collisions. Identify the factors that influence reaction rates. The rate of a reaction can be altered by changing parameters that affect collision frequency or collision energy. Concentration of aqueous/gaseous reactants. More particles per unit volume increases collision frequency. Temperature of the system increases collision frequency and the fraction of particles with energy greater than or equal to EA. Surface area of solid reactants, exposing more reactant particles to collisions. Catalysts, providing an alternative pathway with a lower EA. Analyze the effect of reducing reactant concentration. The concentration of the nitric acid solution used by the rest of the class was extremely high, 15.8 molar. If a student accidentally used a 1.5 molar solution of HNO3, the concentration of hydrogen ions and nitrate ions in the beaker would be reduced by more than a factor of 10. With significantly fewer reactant particles present per unit volume, the frequency of collisions between the aqueous acid ions and the solid copper metal surface decreases drastically, resulting in a much slower reaction rate. Select the correct option. This identifies option C as the only logical explanation for the slower rate. The correct answer is option C. The student used a 1.5 molar solution of HNO3 instead of a 15.8 molar solution of HNO3.